In this lesson, we're discussing how to find the angles in a triangle using sohcahtoa. In the last lesson, we explored sohcahtoa and how to find the different sides in a triangle. In this one, we'll be looking at how to use sohcahtoa to find the angles. Before we get started, I want to remind you that your calculator needs to be in degree mode. So you press the mode button on your calculator and you go to the third line. You make sure degrees is highlighted, selected in dark, and you press enter. And then second mode and to quit that menu. So as long as you're in degree mode, your calculator should be working properly. Now to find the angles using our sohcahtoa, our sine, cosine, and tangent ratios, we were going to have to use the inverse trigonometric functions. So the inverse of the functions, for sine, the inverse of sine is called arcsine, or on your calculator it'll look like this, sine to the -1. This is the inverse of the sine function. For the cosine function, the inverse is the arc cosine, but on your calculator you'll see it as cos to the -1. And for the tangent function, the inverse is arc tan, or tan to the -1. So we're just going to practice using that. So we'll use these two examples. If we're given the sine of x is equal to 0.866, we want to solve for x. So we want to isolate x, get x by itself. Well, basically, you can think of it as we're trying to get sine to the other side of the equal sign. And whenever we bring something over to the other side of the equal sign, or when we try to get rid of something, we want to do the inverse operation. Well, the inverse of sine is sine -1. So we're going to do sine -1 of 0.866. So you'll find sine -1 as the second function of the sine button on your calculator. So take a moment, please, and find it on your calculator. You'll see it's in yellow above the sine button. So I would like you to try to find what this value is. You do sine -1 on your calculator, and then you put in the number 0.866, and you close the bracket and you press enter. Go ahead and try it. You should be getting this number, 59.99. Well, it's so close to 60 that we can round that to 60, and it's degrees, because this x here represents an angle. Remember, it's always our trig function and an angle. So here the angle we would be finding was 60 degrees. Try it now with cosine. So we have cosine of an angle equals 0.457. We're going to get x by itself. So to get x by itself, we basically need to do the opposite of cos and bring it over here. So it becomes cos -1 times 0.457. Do that on your calculator, please. So if you're putting it in correctly in your calculator and you are really in degree mode, then you should be getting this number, 62.8. And it's degrees since we're finding an angle. Now we're going to use these inverse trigonometric functions to solve for angles in our triangles. So we're going to do two different examples where we need to solve for x, and our x is an angle. So my first step in these types of problems is always to label the sides. So since this is the angle we're working with, this is my reference angle, I'm going to label the sides in reference to this angle. So this would be the opposite. This is the hypotenuse, and this is the adjacent. Now I need to decide which trigonometric ratio I can use. So since this is my unknown, I have to make sure the other two sides, or the two sides, I know. I have to make sure I know the other two things. So I'm going to have to use this side and this side. So the trigonometric ratio that we're going to be using is sine, because we have the opposite and the hypotenuse. So sine of x is opposite over hypotenuse. Now I'll put in the numbers I know. Sine of x equals 4 over 5. Now to solve this, we're not going to put this in the calculator yet. We're going to do it all in one step. So I'm going to get x by itself. I'm going to bring sine over to the other side. So it becomes sine inverse, bracket, 4 over 5. So you put that into your calculator in one step. Sine inverse, bracket, 4 divided by 5, and close the bracket. So go ahead and put it in your calculator. You should see that you'll get 53 degrees if you put it in properly. If you didn't get 53, try it again, please, to make sure you're getting it right. Now let's look at this other example. The x here is my reference angle, so I'm going to label the sides accordingly. This one's opposite. My 4 here is the hypotenuse, and the 3 is the adjacent. So my x is my unknown. That means the two sides I have to know. So it has to be the two sides that are given. So the adjacent and the hypotenuse are what I'm going to use. So that's the cosine function. So cosine of x equals adjacent over hypotenuse. So cosine of x is equal to 3 over 4. And then to get x by itself, I bring the cosine to the other side and it becomes the inverse, bracket 3 over 4. Do this in one step on your calculator. Cosine inverse, bracket 3 divided by 4, close the bracket. And I want you to try it on your calculator to make sure you get the same value as I'm getting here, which is 41.4 degrees. This next example here, I want you to try it on your own. Show all your work, please, and we'll go over it in our next class. Now we're going to look at a special type of triangle. We're going to be looking at a triangle that has angles 30, 60, and 90. And here I have an example of that triangle. So we see here we have our 90-degree angle. And if this angle here is 60, well, then this angle has to be 30, so that the angles all add up to 180 degrees. Now, the special relationship in this type of triangle is given here. The length of the hypotenuse is twice the length of the side opposite the 30 degrees. That's always the case when you have a 30, 60, 90 triangle. This other sentence here describes the same thing. These two things are saying the same thing. So the first sentence says that the length of the side opposite the 30-degree angle is half the length of the hypotenuse. And then this one says the same thing, but in the opposite way. The length of the hypotenuse is twice the length of the side opposite the 30 degrees. Now, if that's confusing to you, just cross out that first one. And let's just work with the second sentence. So we're saying that the length of the hypotenuse, so where's the hypotenuse? That's this side here, the longest side. This is twice the length of the side opposite 30 degrees. Well, this is the side opposite 30 degrees. So the hypotenuse is twice the side opposite the 30 degrees. So if the side opposite 30 degrees is x, that means the hypotenuse is 2x. That's the relationship. This side is twice this side when you have a 30, 60, 90 triangle. You might say, well, what's the point of that? Well, we're going to use it in this example. So here, we can already see we have a 90-degree angle and we have a 30-degree angle. Well, we know then that this angle is 60 degrees. Well, now we have a special triangle, our 30, 60, 90 triangle. So since we have that, we can use our special relationship. This hypotenuse is twice the side opposite the 30 degrees, twice this side. We can use that special property to find our side BA. We'll know that BA is going to be equal to 10, my hypotenuse, divided by 2. So my BA is 5 centimeters. You don't really have to use this property. You could have just used a trig ratio because we know the hypotenuse and we know the angle. So if we wanted to find the opposite, we could have just used the sine ratio. That's always possible. You don't have to use this special property, but sometimes it might be useful. Well, now that we know that side BA is 5, I'm going to go ahead and write it in my triangle. Now I need to find the other side. I need to find side AC. Well, I'm going to label my triangle in terms of my 30-degree angle. So this is my hypotenuse, this is my opposite, this is the adjacent. So I have cosine of 30 degrees is equal to adjacent over hypotenuse. That's the ratio I've chosen to use. You could have also used the tangent ratio, but I've chosen to use the cosine, so we'll continue with that. So cosine of 30 equals the adjacent, we don't know, that's AC, side AC we're trying to find, and the hypotenuse is 10. So to solve for side AC, we're going to cross multiply. 10 times cosine of 30 equals 1 times AC, so that's just AC. You should put this in your calculator all in one step, 10 times cosine of 30, and you should get 8.66 centimeters. Now I'm going to ask you to take a look at this other example, and I want you to try this one on your own. I want you to find both sides that are missing. Show all your work and we'll check it together in class.